Okay, last lesson. Wait, let me rewind. Alright, y'all. Oh my gosh, how do people talk like that? Anyways, what's this lesson? Lesson number 2. The last lesson of this week. Last assignment of this week. You've seen this problem on the previous lesson, yeah? And on the previous lesson, all you had to do was estimate the solutions with your eyeballs, yeah? Today's lesson, I'm going to show you how to solve this algebraically. So, buckle up. Hold on to your britches. I love saying that, especially because students think when I say britches, I'm saying something else because they don't know what britches are. So, we're going to do this together. Take notes. Follow along. I will say this. A degree problem, when you see theta, is a degree problem. Those are going to be way easier than radian problems. Just saying. Just saying. Okay. There's going to be 4 problems where we actually tell you the equation. 2 of the 4 will be degrees. 2 of the 4 will be radians. Sorry about the pain you're about to feel. And then there's 4 more problems where we don't even tell you the equation. We just give you a graph, and you got to figure out what the equation is. That's called dirty. Yeah, we'll go over a couple of those also. So if you're not good at writing equations for graphs, you might want to go back and redo that lesson, or look at the comments I sent you. Yeah, because obviously if you don't write the equation correctly, you ain't going to solve it correctly. But here we go. On a sheet of paper. -1 plus 3 times the tangent of 2 times theta minus 20 degrees equals 3. Yeah? So, just like solving equations in first year algebra, you're just working backwards, right? The nice thing is it's set up in such a way that first you get rid of that, then you get rid of that, then you get rid of that. That's the hard part, by the way. Then you get rid of that, then you get rid of that. Done. So how many steps was that? 4-ish? 4-ish steps. Step number 1. Add 1 to both sides. Add 1. You're in pre-calculus. I don't need you to see the work. I don't need to see this work. Oops. So you get 3 times. I'm going to actually put the dot there, because it's important that you understand that it's multiplying right there. And I know what you're thinking. Why is my work so beautiful? I just can't help it. Just like my hair. Beautiful. How we get rid of this 3? We got to divide both sides by 3. Again, I don't need to see that. That's first year algebra nonsense. I don't need to see it. Bam, bam. But if you're going to do it right. Shoot. And then you get tangent of 2 is equal to, or tangent of 2 times theta minus 20 degrees is equal to 4/3. I would leave it as fraction. If you want to change it to a decimal, just make sure you write 1.333. 4 decimal places should be good enough. Okay, I'm going to leave it as a fraction. And this is part of previous lesson. This equation is harder than the equations on the first assignment for this week, but the concept is the same. To get rid of tangent, you're going to do not inverse tangent, because inverse tangent only gives you 1 answer, and we want all of those answers. There's 4 of them that we can see. How many are there in a reality? Infinite number. But so take the arctangent of both sides, take the arctangent of that side. I'm not going to show it. Okay, I'm going to show it. Arctan. If you're going to do it right though. That's shoot. cancel this, and then you get 2 times theta minus 20 equals the arctangent of 4. I'm not going to rewrite that because I feel like that's a waste. So watch what I do. Watch what I do. Instead of rewriting this here, I'm going to go straight to the general solution. Arctangent is just like inverse tangent. Yeah? Except there are an infinite number of other answers. And this is a degree problem. Period for tangent is 180 degrees times n, because there's an infinite number. N stands for number. Yeah. So this will give us just one answer. Adding 180 times n gives you an infinite number of answers. Also, by the way, every textbook I've ever seen always has plus here, but in reality, plugging that into the calculator will give us this answer, and then adding will get us those answers. So obviously you need to go backwards, right? Backwards is subtraction. So in reality, I don't know why authors don't write it like this. They're math people, I don't get it. But this should be a plus or minus. Plus is for going to the right, minus going to the left. Yeah. Anyways. But teach this a little bit differently than I do during the school year. Watch what I do. Watch what I do. Watch what I do. This is an added step. I am gonna just go ahead and plug that into the calculator right now. Yeah. And I think this is gonna make your life easier. I hope it's gonna make your life easier. Okay. So keep in mind, this is a degree problem, so whatever calculator you're using, make sure you're in degree mode. Inverse tangent of 4/3, 4 divided by 3, so 53.13 degrees. I am going, how about this? Degree problems, you round it to the nearest whole number, and radian problems, 2 decimal places, because pi is 3.14-ish. So if you're doing a radian problem, 2 decimal places. If you're doing a degree problem, just round it to the nearest degree. Okay? 53 degrees. So 53 degrees plus 180 degrees times n. Yeah. And now I divide by 2 on both sides. Oh, pay attention to this step. Should divide left side by 2. Divide the whole right side, the whole side by 2. Cancel. Theta minus 20 degrees is equal to about 53 divided by 2. I don't know. 27.5. That's my brain not working. My calculator not working. Mother dookie. 53 divided by 2. You ever have 26.5? See, I said 27.5 because I'm an idiot. 26.5 degrees, and then 180 n divided by 2 is 90 n. If you don't have the degrees there, I'm not going to be too upset with you. But your final answer, you have to label it in degrees, okay? But if you don't want to put degrees, that's fine. Last step, add 20. Add 20. Yeah, why didn't I write it over here? Because they wouldn't be like terms, right? So, there's a lot of math going on, here. Theta is approximately equal to 46.5 degrees plus 90. This is called the general solution. Yeah. Now, let's take a look at our estimates. I estimated 45. Turns out I was pretty stinking close. It's actually 46.5. And then now let's write the particular solutions. So we got 46.5. That's the first one. That's that guy right there. And then add another 90. Why? Because it says so right there. Plus we can tell by the graph that the period was 90. Plus we can tell by the equation the period is 90. So that makes sense, right? So you're adding 90 to that. 46.5. Enter. Plus 90. Enter. 136.5. What was my guess? 135. That's close. Enter. 226.5. What was my guess? 225. Pretty close. Pretty close. Yeah. And then of course I have to go backwards to get. So I got this one. I have this one. I have this one. I don't have that one on my paper, so I need to go backwards. See what I'm saying? That's why I should say plus minus, but it doesn't. Because I don't know what's wrong with them. Bam. Negative 43.5. What was my guess? Negative 45. Pretty close. So your eyeball estimates should be close. Yeah. 1, 2, 3, 4 answers. Why do I have 4 answers? Because there's 4 answers shown on the graph. So make sure your answers match. Yeah. If they don't, and they're not even close, then you did something wrong algebraically. Or you could be in the wrong mode. Look at that. That's one problem. You got to do that 8 times. 8 times. That's a lot. That's a lot. Stay tuned. I might shorten the assignment. We'll see. That's a lot. Look at all that work. Okay. Next video, I'm just going to do more examples, okay? But I'm just going to stick with just the pure algebra. I'm not going to refer back to a graph or anything. Actually, that's not true. Sorry, guys. Complicated stuff. Complicated. It is pre-cal, though. So, I'm going to have to do this in 2 videos. Sorry, guys. Oh, one more thing. Sorry. That's the general solution. These are called the particular solutions. Yes, you do have to label them. Why am I writing so simple today? I don't know.